the presentation. I'm going to proceed the analysis in this particular case. That is, the first is logistic regression, then objectives of logistic regression, then how to check the accuracy of the data, and then application of logistic regression in different domains, and the case use analysis using SPSS. So first, to start with, what is the meaning of logistic regression? Logical regression is nothing but no, which helps to predict the probability of a dependent variable. Dependent in this case, here it is a binary outcome. Binary means there are no, two classifications. It can be yes or no, or it can be they say default, not default, loyal, not loyal, etc. So I will explain to you the other example of the dependent variable, which is a binary in nature, and it is based on the one or more independent variables. And when you say the no, further you explain, as I mentioned to you, the dependent variable should be categorical in nature. Okay, so categorical means only two outcomes. Example, yes or no, or true or false, then success or failure of any particular activity, then default or not default category, then loyal or disloyal customers, then purchase or not purchase customers, then satisfactory and not satisfactory in customer category also, or in employee category also. So these are the examples that I wanted to tell you. And then disease and non-disease category. So particularly, this particular logical regression is used for classification problems. Then, okay, next to make it more simpler, it explains the relationship between the dependent variable and independent variable categories. So here, the independent variable which is going to be considered can be continuous or categorical. Okay, independent variable, and here we are going to try to estimate the probability of the output that we are going to predict is correctly classified. That is what the aim of the analysis is. Then main objective is to that is define the dependent variable according to a class, that it belongs to a certain class. Say yes or no, as it was mentioned earlier, that so many people or so many respondents belong to S category, and so many people belong to the no category. So that is what we are going to estimate and also predict the outcome, that yes is because of what and no is because of what. Okay, so example, one of the example you can say is that to predict whether a user will complete a purchase based on their behavioral data collected during a visit to the e-commerce website. Okay, so when a customer visits the e-commerce website, how does he behave? Whether he the cart, or he puts all the items in the cart, okay, and how much time he's spending in the e-commerce website, all those matters. So example is given here in the next slide. Say, for example, here the dependent variable will be that to predict the purchase category, whether in the future, because of what factors they will likely to purchase. Okay, likely to purchase and not likely to purchase. Okay, so two categories, yes or no. Then you can ask this in you can use the logistic regression in predicting the outcome variables. So the independent variables, if you say it is the time spent on site, okay, it is a continuous variable, and you can ask in the questionnaire saying that approximately how much time did you spend on the website. And this next independent variable can be purchase intent. That is, did you intend to make a purchase today? So it can be yes, maybe, or no options. And with this also you can analyze whether they will purchase in the future or not. Then trust in the website. That the question can be, I trust this website with my informations, and it can be in the Likert scale, 1 to 5 scale. Then ease of navigation. Ease of navigation, you can ask a question like, I found it easy to navigate the website. Okay, so that is also in the 1 to 5 scale. So with these independent factors, you can really predict the purchase behavior of the customer. Okay, so here the objective, as I mentioned to you, you have to state the problem, that is to predict the probability of the dependent variable. There's a purchase behavior, whether yes or no, based on the input variables that is mentioned in the previous slide. Okay, so here when you are going into the logistic regression, very important that is matrix that you have the software will try to come out. Okay, it will give you the output as a confusion matrix. So in the confusion matrix, it is also a classification table. Suppose you have a respondent, you have a 10 respondents with you. It's just an assumed number, 10 respondents, and in that you have S5 and no 5. Okay, the respondents who say yes, they will purchase, and they five people say that they don't purchase. So if you have this, so how do you estimate the accuracy of the classification, that they have said 5 and they have said yes or no? So it is a matrix that you have to come out. Say this is the matrix that the software will try to build. So here, when you see the left side, you have actual yes or no. Okay, and on top you have the predicted data through the software, that we have got the yes or no data. So, but actually, what you have got in the your response is yes 5 and no 5. But after the analysis has been done, okay, the predicted value says that, okay, under the S category there are only 4, and the one category that you have included in S should be under the no category. So this is a procedure which the logistic regression analyzes, okay, and finds out the accuracy of the classification. So in the actual no category, there are 5 response, and after the analysis, it is said that all the 5 who has said no are truly coming under the no category. So there is no deviation under that. So when you have a such classification table or model that is you have derived after the analysis, so what is the accuracy of it? The accuracy here is 90%. So how do you arrive at the 90% accuracy? Okay, so here they take a cutoff of 0.5 category. Okay, so by applying a formula, there is a formula to categories. But for you, it is not necessary to calculate the accuracy of 90% and all manually. Okay, because it will automatically be given in the software. Okay, output. So I'm just explaining you the how it has been arrived at. So here it is the actual true or false. As you see here, S is the true value and no is the false value. Okay, that is what written here. And under the predicted value, as you can see, S is the S and no are on the top. And here you can see that S is the true value and no is the false value. So when you have true and true combination, it is called as true positive. And when you have true and false combination, it's called as false positive. When you have actual false and predicted true, it is called as false negative. The true negative. Okay, so this is a combination of the actual and the predicted values. So here the accuracy is as I have put the values here that we have assumed to be there in the table, right? So here there is a formula. Okay, this formula is nothing but where accuracy is equal to TP. TP here means true positive and plus true negative TN. So divided by all the Here it is the 4 plus 5 divided by 4 plus 5, 1 plus 0 plus 5. So this the value gives us 90%. Calculate manually. Okay. So now the guidelines for the and if it is 50 to 60, it is poor accuracy. And then when it is the 60 to 70, it is weak to fair. Okay. So your next few categories are like 70 to 80, fair to good, and 80 to 90, good, and 90 to 95, very good, and above 95, it is excellent. Okay. So these are the the criterias or the guidelines through which you can check the accuracy in your data. If you have no less than 70 or 65, you can better go for no reviving your data. Okay, so that I'll explain to you at the end how you do it. So one more classification no proof or the classification that has been obtained is the correctly been done is through one more tool that is called as ROC curve. So ROC curve is nothing but receiver operating characteristic curve, which is a graphical representation showing you the classification of the outcome variable. Okay, so I'll explain to you with a graph, and it also measures the AUC. AUC here means area under curve. Area under curve here gives you values between 0 to 1. Okay, 0 to 1. So if you have value equal to 1, it is a perfect classifier, and if it is zero point 0.5, it is it is not considered as a good classifier. Okay, but it is between 7 to zero point 0.8, it is acceptable, and zero point 0.8 to zero point 0.9, it is excellent. Okay, so higher the AUC, better the model. So this is how the ROC curve will look like, and the diagonal green color is the 0.5 cutoff, where which is the no ideal line which has to be there, but it is the above line. When you see the darker curve, the blue color curve, which is there above the diagonal line, it should be away. It should be away from the suppose the value of the AUC is say 0.9, it will be far away from the diagonal. And if it is zero point 0.6 or something, it will be a little bit closer. But this seems to be halfway through. Okay, not perfect one, and not nearing to the 5. So it is halfway through. It might be a 0.7. The area under curve will be like 0.75 example. Okay, so this if this is the case, this is a better classification model. Okay, next is the I'll give you certain examples under no, different domains, finance or the marketing and operations. Okay, and HR. So you will understand how certain problem statements can be used no, for your research work, right? So, sir, I'm audible. I'm audible, sir.
Yes, ma'am. Yes, ma'am. You are audible.
Yes, okay, fine, fine. Yes. So here, finance examples. Those who are interested in doing finance, no, projects or no, want to do analysis. So these are the few topics that you can use it. I have just given few, but you can relate it. Okay. The first one, you can say that you want to find out or predict the loan defaulters. That is a common example that I know everybody no, uses it, and I will explain in a case use analysis with this particular no, objective. That is predicting the how many of them will default. Okay, given their pattern of no spending pattern or their income pattern, etc. Okay, so next example is under the finance. You can predict the IPO success using the historical IPO data. Okay, so how a particular company's IPO will no, be successful in the near future using their no, earlier data. Okay. Next, very frequently used is the stock market crash. prediction based on economic indicators, and also news sentiments. Okay, so that also you can use the logistic regression, and also bankruptcy for predicting the bankruptcy of the financial with the help of the financial ratios. So you have a set of financial ratios, and you find out whether a particular bank will be in the future will go for bankrupt, or it will not go for bankrupt. Okay, then you can analyze the credit card fraud detection, whether a particular a person or an individual will do a fraud using their credit card by not paying it, or misusing it for some other purpose by using their transaction data. Okay, then next, coming to the marketing domain, and the various topics that you can cover or use the objectives, such as no, customer churn prediction. So you know what is customer churn? Customer churn is that losing your customer, right? How many customers will that is the attrition. That is how much they will not buy the product, or they will leave the company's product and switch on to the others, right? So that is the customer churn prediction. And social media impact, campaign impact on the sales. So for that also you can use the logistic regression. Then customer purchase prediction, whether he will purchase or not. Okay. Then influence of discounts on purchase decision, and then brand switching, whether a particular customer will switch to another brand or not. So okay. So on the basis of service quality dimensions of a particular company. Okay. So remember, please, all the dependent variables that we are going to consider here are the binary outcomes. Okay, two classification, either yes or no, that I mentioned earlier, yes or no, loyal, disloyal. Okay, then you can have a satisfaction, not satisfaction, like that. Okay, so next, a human resource domain. Under the human resource domain, you can have objectives such as the employee turnover prediction. You can predict the employee turnover, whether he will they will stick on to the company or not. Okay, so next is the absenteeism prediction, whether no in the future they are going to absent themselves or not on the basis of their behavioral in the organization. Okay, and predicting employee satisfaction, that I mentioned earlier. And next comes the identifying the risk of employee burnout. So whether he is really whether he's a burnout or not. Okay, so that is the outcome variable, and this is a risk factor for the organization. And this can be found out by using the independent variables, that whether he is stressed in the organization, whether his workload is more. Okay, with all those independent variables, you can find out the outcome variable. Then predicting effectiveness of the mentorship program or the training program, whether it was effective or not effective, right? With a certain set of criteria that explains the dependent variable. So these are the certain objectives that you can take up for the HR domain. Next, the operations domain. The research work can be concentrated on predicting on-time delivery. Okay, then predicting supplier reliability, and then predicting inventory stockouts, and also predicting on-time shipment, then predicting vehicle breakdown during delivery, and predicting load optimization effectiveness. Okay, so these operation students, logistics students, okay, can take up objectives like this and try to predict this outcome variable. So now I have explained to you. If you have any doubt in this four domains objectives, you can ask me, or you can put it in the chat, so that my staff people will read it through and they will ask me. Okay, then I'll wait for 1 minute. If no one is asking question, I will proceed with it, because I'm entering into the use case analysis. Use case analysis.
Ma'am, one person has asked that about the tools.
Yes.
Which software, which tool we can use?
Yeah, I'm going to use only logistic regression. And for logistic regression, I will let you know what are the no, output that you have to generate and how you have to interpret those.
Ma'am,
Yes.
Dr. Sindhu wants to know which is the software package.
Software. They're asking what they're asking, sir?
Which software package? Which are all the software packages can be used?
You can use SPSS, you can use the SAS, you can use Stata, you can use
R project also.
R also you can use by using Python also you can use. But for social research for people like us, we are more comfortable with SPSS, and there are two more I'll show you. Yeah, see, in my next slide, you have these two open source softwares, PSPP and Jamovi. Okay, these are the two open source software that I'll show you how does it work with that. Okay, in my forthcoming slides. First, let me explain with SPSS first, and then I will show you how it works with the PSPP and Jamovi. See, when you go with
any other persons, any other doubts? Whether you can able to point whether this can be done on logistic regression, or my idea is like this, is it okay? That kind of doubts also you can raise. Ma'am will answer. Yes. What best you can do it.
Okay, so I hope you have understood in what areas you can do the apply this logistic regression, because I have extensively mentioned the example for each domain. Okay, so as I mentioned here, three different softwares are there, very prominently used, rather than Stata or the SAS, right? These are the very user-friendly softwares. Okay, so now let me go with the SPSS no case use analysis. First, I will no, explain to you the model fit tables that are necessary for this particular logistic regression. So first and foremost, the model fit table one has to be obtained by the table is known as the omnibus test of model coefficient, and here it tests the chi-square test, okay, where it predicts, to explain how the well the prediction of the outcome is. Okay, so here if the p-value of this particular test is less than 0.05, it is said to be well predicted. Okay, it has a predictive capability of the outcome variable. Next, the second table, all these three comes together, and each one has its own significance, and it is very important in the logistic regression, as you have the R square and adjusted R square in the linear regression. Okay, so here it is the -2 log likelihood test, where if the value is lower means closer to zero, and less closer to zero means it can be both positive or negative. So here closer to lesser values will mean that, what does it mean? It explains that unexplained variations of for the model, that is there is a less impact of the unexplained one. So whatever the variable that you have taken into consideration has a good explanation. That is what it means to say. Okay, next is the Cox and Snell R square, and it should be closer to 1. Okay, it is similar to your R square that you get in the linear regression, and the model explains the variation in the output, right? Outcome variation. And Nagle-Kirk R square is the adjusted R square. Similar to your adjusted R square in the regression analysis, and it should also be closer to 1. So it takes into account all the variables and also the not variables that is not considered in the analysis, and calculate the adjusted R square. Okay, so this is how the three important model fit criteria are necessary. Okay, next, the third is the Hosmer-Lemeshow test, which is also important, and it shows that the value of this is should be no greater than 0.05 level of significance, and it means that it is a good fit. Okay, so this particular test is no opposite of the earlier one, there where we have to estimate, we have to get the greater than 0.05 level of significance value, so that it says that there is a significant difference between the observed and the predicted value. So if there is a little bit difference, then only we have the significant difference. Otherwise, there is no significant difference. Okay, so there should be some difference. If suppose they are equal, if we find that there is no significant difference between observed and predicted, there is some yourself will know that from seeing the data that everything is perfectly been classified. So that is not the objective of our study. Okay, our study is to really find out whether there is a difference, and if there is a difference, how it has been different. Okay, so that is what we want to find out. If there is no significant difference, there is no need for doing this particular analysis. Okay, so next, very important, as I mentioned to you earlier, the confusion matrix or the classification table. The actual and the predicted data is being calculated and shown in this, and here you get the accuracy value, and that is what the overall percentage that is mentioned at the bottom. This is just an example where it shows that it is 76.4. Okay, so it is 76.4 is a okay, fair fit. Okay, not a very bad the next level, but you can consider it for the predictive analysis. Okay, so this is the coefficient table similar to your coefficient table in the regression analysis, where you have the independent variable 1, 2, 3, 4, and you also have constant, and here you have walled test, and the value and significant value is being given, the beta value is given, and the last one is the exponential beta value, that is nothing but the exponential of the beta value. Okay, so here there is a condition that's saying that with the exponential beta that I mentioned here at the last column. Okay, that explanation is very important. Why? Because to explain the changes in the dependent variable due to the independent, how much it will change, that will be explained with the help of the exponential beta value. Okay, so here it is called as odds ratio. It is also called as odds ratio, and it is the exponential form of the beta value. Okay, so if or is nothing but the odds ratio or the exponential beta value, if it is equal to 1, no effect on the odds. Okay, no effect on the dependent variable. And if the odds ratio is greater than 1, the increase in the there is increase in the outcome of variable, and if the OR is less than 1, it indicates that there is a decrease in the odds or the outcome variable. Okay, so I will explain to you once I show you the so now I'm going to explain a particular problem from the finance domain. Okay, let the problem statement be the to predict the defaulting on loan using a set of demographic and financial characteristics. Okay, so here you have to first define the no the dependent variable. What is the dependent variable here? The dependent variable, I'm going to take it as the loan default. You will have a data, okay, in where you will know that that particular customer, okay, or the individual has defaulted or not. If he has defaulted, it is S category, and if he has not defaulted, it is no category. Okay, so that is what the dependent variable is. Next, the independent variable. Here I have taken the demographic variable as age, which is shown as the continuous variable, and household income is also as a continuous variable, and credit card debt. Okay, so a person will have a credit card with him, and how much debt he has with that. He's not paying it properly. If he's not paying it properly, it might be a 0, or if he is paying it, how much amount, and that also in thousands. Okay, in rupees or dollars, whichever currency that you want to mention, you can mention it in the thousands, or any particular measurement that you want to take it. Then other variable I have taken this as other debt. That is also a continuous. Other debt is not which is not there in the credit card. You might have debt no in the case of, say, a loan. That is a loan that you have borrowed for the housing loan, right? Housing loan, you have got it, and for education loan, you would have got it. Okay, if that debt you have, and whether you are repaying that debt properly or not. Okay, so that is also being considered here in this particular example. Okay, so with this, I will show it to you by using the SPSS software. Let me go to the okay, 1 minute. Okay, so here, can you see my can you see my this one screen?
Yes, ma'am. Your screen is visible, ma'am.
Yes, okay. So here, see, I have posted the Excel sheet also, and I have no the SAV format which is being stored in the SPSS. Okay, so I have opened that. Okay, so I will. I think everybody knows how to open the no SPSS sheet, right? So here, when you open it, the concern data sheet with you, you have two windows, data view and the variable view. If you see in variable view, you have age, education, employment. Okay, here it is mentioned as, see, a label you can see, then address of the individual, income, household income in thousands, and then debt to income ratio, and credit card debt in thousands, and other debt in thousands. Okay, and the outcome variable, that is the default variable, and that is the previously defaulted. Okay, so if you see this, this is a binary, that is no and s. Okay, no is 0 and 1 is s. Okay, this is the outcome variable. And here you have all, as I mentioned to you, age is a continuous scale variable, and here I'm going to consider income is also scale, and debt to I'm not going to consider debt to income. Okay, and then credit card debt I'm going to consider, that is a scale, and other debt in thousands is scale. Okay, so here when you look into the data view, this is how the data view looks like. Okay, so this is how it looks like. Okay, now we go to the no, I'll show you the Word document, if step by step, no, your procedure, if you need it, I can explain to you, or it is there in the, let me check whether it is there. Yes, this procedure is there in this. Okay, what you have to do for no, solving this particular yes. So here, first you have to define the research question and frame the hypothesis. Okay, then prepare your data, then check assumptions for the logistics regression, then run the logistics regression in SPSS, then interpret the output and report the results. Okay, so when you define, I have already given you the problem. The problem here is that I'll show you the problem here. I hope you can see this particular Word document. Yes, it is visible. It is visible, sir.
Yes, ma'am. It is visible, ma'am.
Okay, okay, fine. I need to close this. Okay, no problem. I think the screen is bigger. Okay, now here the finance case analysis. Here the research question is that to predict the defaulting on loan using a set of demographic and financial characteristics. So what is the hypothesis? And I have explained to you what are the demographic variable and the financial characteristics that I have taken for the study. So here the null hypothesis will be that the independent variable, okay, the age, income, credit card, loan, and other debt do not significantly predict the likelihood of loan default. And the alternative hypothesis is at least one of the independent variables significantly predict the likelihood of the loan default. Okay, so this is the next one comes the your data. You already your data, you have to clean it, as sir has mentioned in the previous session. Okay, that you have to clean the data, missing values, outliers, all you have to check it out. And then dependent variable, you have to see to that it is in binary coding. Okay, and then you have to check for the variable types, whether it is a independent variables, whether they are categorical or continuous. Okay, then you have to check the assumption is nothing but there is no multicollinearity where the independent variables that you're considering are not related to each other. Okay, so as I for this case I have taken credit card debt, and I have taken the other debt. So both are independent of each other, so they don't relate to each other, right? So that is what they mean to say here. You have to take the variables that are no independent of each other. So income is also an independent factor. No, age is also an independent factor, right? So and there is a linearity in the continuous variables. That is, there should be a pattern. Okay, there's a pattern. When one increases, others increase. When one decrease, others decrease. When one increases, others should decrease. So that is what the linearity and logic for continuous variables. Okay, then independent observation, as I mentioned to you, the cases should be independent of each other. So if that you have, automatically there will be multicollinearity, no multicollinearity problem. Okay, then you have to run the logistic regression. I have given the no steps here. You can go through. I will explain to you live how to do it. Then interpret the output. Okay, so and report the results. Okay, now I will go to the data, and the data here is the bank loan. Bank loan is the data here, and here I'm going to analyze. Click analyze. Here you can see regression. Regression. In the regression, you can go to the binary logistics. Okay, there is a option here, binary logistics. Click binary logistics. Okay, so as I mentioned to you, the dependent variable is the previously defaulted value. But it is in yes or no category, right? Select that previously defaulted and put it in the dependent box, text box, and then under the covariates, you can know, as I mentioned to you, we are going to take the age, we are going to take the household income. Okay, and then we are going to take the credit card debt, and we are going to take the other debt. Okay, so these are the four variables that you're going to take as the independent variable. And in this, if you see, all are the continuous variables, so there is no further process to be done because all are continuous. If you have say income in category or age in category, you have a particular procedure to be followed that I'll explain to you when I explain the marketing domain example. Okay, so now for this there's no further procedure to be followed once you enter the independent variable into it. Okay, and then go to options here. As you can see in the right hand side, the third no item is the option category, where you click the option. Under the option, you have the statistics and plots. You click the classification plots, you click the Hosmer Lemshow goodness of fit, and you click the CI for exponential beta value, that is the 95% confidence interval, you take it. Okay, so these are the three important no, tools or the criterias that you have to click it. Okay, and then continue. Okay, then continue, right? So here there is another very important one that you have to do. See, once the software calculates the outputs, right? We have to save the predicted value. We have to save the predicted value. So go to save, go to save. So in save option, you just click the predicted values, that the probabilities and also group membership. Okay, both you can click it together. Okay, you can click it and then continue. This is essential to find out whether there is an accuracy in the classification based on ROC, based on ROC. Okay, so these two are very important ones. So you have to click that and then go to OK. Click OK, and you will have the output here. You will have the output table. I hope the output table is visible to you. Okay, so here if this, you see the output here, Okay, these are the beginning tables. The beginning tables are the summaries of the actual values. Okay, but we are interested in the table that I mentioned to you in the PPT. Okay, it starts from this particular section. That is the block one method, enter method it has used, and this is the omnibus test model coefficient table. And here it gives you the no a chi-square value, the degrees of freedom, and the significance value. Okay, and model summary of all the R square value is being given here. Okay, and here the next is the Hosmer and Lemshow test value. Here it has been given, and the next, if you see, it is the contingency table for Hosmer as this is not necessary. This is not necessary. Okay, next comes the classification table. The classification table, if you see, the overall percentage is 77.3 here. Okay, so I will explain to you in a more better manner. I have put that the same tables in the Word, and it will be bigger in size, and it will be visible clearly. And in the output table, you can see the last table is the variable in the equation, the beta coefficient value, the significance value that is there in the no 1, 2, 3, 4, 5, sixth column, and the exponential beta value that is given here. Okay, I'll explain to you one by one, and we can see that in the yes. So here, when you go through, I'll go to the Word document. Okay, so in the Word document, I'm trying to hide this. Yeah. Okay, here it is the model fit table 1. Okay, the same value is being copied there and pasted here. So here, if you see, I've taken all the values, three different models have been evaluated, and the same value is being given here, and it is significant, right? So what does this Omni test tell you about, which I gave you in the PPT, is that it really, has a good fit for predicting the that is the variables, independent variables that you have taken into consideration are well explained. It explains the outcome variable. That is what it can be used for the predicting the outcome variable. It really fits it. Okay. Next, table 2, if you see, it shows you that the three different values. Here it is the it says that lesser value, right? But here it is the higher value, which is 680. So comparative, it is high. So it is showing a higher value because, as you saw the predictive percentage, that is the 77 percentage, right? So if you have closer to 80, 85, and 90, your log likelihood value will be lesser. Okay. So, but looking into this alone is not sufficient enough to predict the outcome variable. So you can go ahead if other parameters really satisfy it. So here the R square is 0.163 and adjusted R square is 0.238. So it is you can include few more independent variables to explain the outcome variable. Okay, to improve this R square. Okay, let us see how the predictive value is and how the ROC is. Okay, so if you see this particular Hosmer and Lemshow test, here the criteria that was mentioned there was that this is significance value, the p value 0.129 is greater than the 0.05. Okay, level of significance. So what does it say? That it has a good fit. It is a good fit, and you can explain the outcome variable with the help of the this one. So there may be some contradictory with the other one, but you can use your what to say, knowledge, or you can judgment whether to use this particular case analysis or this particular problem for further analysis, right? Why? Because I'm telling you is, go to the classification table. If you have a very less percentage, okay, less than 70 or less than 65, you can really need not proceed with the next level. Okay, but so this since the classification table is 77.3, you can proceed with the classification prediction, this particular logistic regression, as it says that. So here, as you know, the no is 497, and no S is 20, yes no is 139, and S is 44. Okay, so here no, you have 96.1 percentage as correctly been identified, and in this category 24. But overall, when you see, it is 77.3 percentage which is being no, accurately being categorized. So here you have the ROC curve. So under the ROC, I have mentioned to you the values and its guidelines. Okay, this is how the ROC curve is obtained for that. How to obtain the ROC? Okay, I will explain to you how to obtain. Since in the previous no, this particular bank loan case, I have told you to save the predicted value, right? Save the predicted value. So here you can see at the end, right? You can see in the variable view also. You can see in the variable view that here you can see the 10th and the 11th variable. Okay, this is the predicted value, and this is the group membership. Okay, so how you have to consider this group yes or no category, whether the predicted value it will consider, and it will find out what is the accuracy, right? So here it said 77 percentage accurate accuracy. Okay, now we will try to no, further prove with the help of the ROC curve, as I mentioned to you earlier. So now go to analyze. Okay, then you see at the end there is a ROC curve. Okay, ROC curve. You click the ROC curve here. Okay, here in the test variable, you take the predicted group variable, predicted group. Okay, what you have estimated from the no, analysis, predicted group, and in the state variable, you try to take the previously defaulted, which is actual no, default group, right? Actual, select that and put it in the state variable. So there is another very important no, element that has to be taken care of to mention the value of the state variable. So here always we have to mention the higher value. Higher value. So what is the higher value? For no, we have stated 0, and for S we have stated 1, value 1. So we have to take the higher value. Higher value is always 1, which has to be mentioned in this. And here in this particular below, you can see that display ROC curve, and the you have to also click with diagonal reference line. So the cutoff point is the 0.5. 0.5 is the cutoff line which will be shown in the graph, and above the graph there should be a deviation. Your predicted value should be above the line. Okay, above the diagonal line. So we click this OK and find out what is the ROC. See here. So in this case, this 77, it is really no, little bit far away from it, right? So here, this we will see AUC. How much is the AUC? AUC is here actually 0.601. But earlier case where I have mentioned is the 770. So if it is 70, it will be good. Suppose if you see that it is 0.60, you can do some modification. Not modification as such, but you can include one or two variables, and then try to do this analysis once again, and see to that your area under curve is above 0.7. Okay, so that will be better to explain. So if suppose I take debt to income ratio, if I take that variable into consideration, we will see how does it behave. Okay, so in this, along with this, I try to take debt to income ratio. Okay, I take this as another variable, and go for the no, all are defaultly clicked, and click OK. So let me see what is the outcome variable. It is again saying 7.77 only, right? So but there is a slight change in the no, S category. Earlier it was 24, and now it has become as 31. Okay, so if you put let us see whether there is a change in the predicted value. Let me check in the predicted value. See, again, there is another predicted value group found here. Okay, we go to the ROC. We will see whether there is a change. Whether there is a change. ROC. Okay, I reset this once again. Go to the predicted new predicted value and take the earlier actual predicted value. Okay, and click it here. Enter one, and sorry, there is no diagonal line represented, but you can just guess that it is a little bit no improved version from the previous one. Okay, so now as these are explained to you, now we will go to the further explanation of the coefficient table. Okay, so now we get an area under, oh, we didn't check the area under. Let us check the area under this one. Under this, if you see, I think 6.623. Okay, so there is a slight improvement in the area under curve. Okay, so now let us explain the coefficient table. Coefficient table. I hope the coefficient table is visible to you. Okay, where you have all the variables, independent variables here: age in years, income, credit card debt, other debt. Okay, I didn't include the debt ratio. If that is also included, you can no, there will be different variables here. Then I have to change it. So I explain with this. You can add the variables if you are including it and enter the data. Okay. So here, the first one, you have to check the significance value. These are the first initial step that you should check the significance value, whether this particular p value is lesser than the 0.05. When you check all the values, okay, all the values are less than 0.05. So all the independent variables influence the outcome variable. So how it affects, that you have to check with the exponential exponential beta value. See how it has been interpreted here is that, see, check out here, that, see here, if you take the age factor and the income factor, it is closer to 1. Okay, it is closer to 1, and any change in no the independent variable, it will change the outcome variable. Say for example, it is coming negative. So when it comes negative, so it shows that as the age increases. Yes, yes, please. Any one of them, please, no, unmuted and wanted to explain something. Okay, so here if you see the there is a negative coefficient, right? When the negative coefficient is there, it means that that is the exponential value is 0.953 that I mentioned. I showed you there. For each unit of increase in age, okay, your default level will decrease by 5%. Okay, so the age category in the 5% of the age category will decrease. Okay, so you can take if the age is given in continuous manner, you can say that from 50 to 45, like that it will go on decreasing. Okay, so from maximum value to minimum value, so it will go on decreasing. So that is a relationship between the age and the default. So there is a negative relationship. Okay, next is the household. Household is also showing the negative relationship, and here also it's showing that by how much, if 1 unit of you know independent household income reduces, how much it will change. It will change by, say, it will the default will decrease by 2%. It, because see, if you take this as 0.98, okay, and you minus it with no 1, okay, so how much it will be? It will be 2, okay, 0.02, 0.02, and so it says 2%. So here in this case 5%, because 1 minus 0.95, it is 5%. Okay, so that is how you have to interpret this particular variable. Next comes the credit card debt. Credit card debt, again you have here significant. So here if you see exponential beta value, it is 1.757. So if it is positive, it is positive. How to interpret this? Okay, so here it says that for every 1 unit, uh, change in the credit card debt. That is the independent variable. How much change it will bring? It will increase because it is positive. Since it is positive, you have to say that it will increase by 70. See here, I'll show you here. Okay. Yes, credit card. It will change. It will increase about 1.4 times for each 1,000 units increase in credit card debt. Okay, for every 1 unit increase in credit card debt, your loan default case will be 1.4 times. Okay, so that is the interpretation that you're going to give it here. So similarly for other debt also, other debt, how much it is affecting is the exponential beta value is 1.089. Okay, and it means that for every 1 unit increase in other debt, okay, there will be an increase in the default will one time is it will increase. Okay, so this is how you have to explain the this particular no, output. Okay, so I hope you have understood. Now you can say that when you generalize this, what you generalize here, you generalize that all the independent variables influences the default variable, and the more powerful variable which is no influencing the default category, okay, is the credit card debt, okay, followed by the other debt. Okay, so these are the very important variable, independent variable, which affects us, as it is shown through the exponential beta value also and the beta value also. Okay, so this is how a finance domain problem statement can be analyzed. Okay, so hope you have understood this particular one. I'll explain one more with the marketing. Any doubt in this financial cases, you can ask me. Any uh, any doubts here? I'll go with the next marketing. I'll give you 1 minute time. Marketing. You can ask any question. Okay. So now with the marketing problem statement, we will try to analyze, okay, or to predict the customer purchase decisions using the demographic and the uh, variables that 1 minute, sorry. Yes, with the demographic variable and the behavioral data. Okay, so objective here is to identify the most influential factors that drive the purchasing behavior, quantify the strength and direction of each factors, and build the predictive model. Okay, and here if you see the dependent variable and the independent variables are given here. The dependent variable is the purchase variable, yes or no. Okay, the outcome variable which are in binary in nature. And next you have the independent variables. I'm considering income variable, which is continuous. Then browsing time in the website, okay, continuous in minutes. Okay, and promo clicked is whether any particular promotional activity promotion that is given in the website, and they are clicking that promotional ad within the website or not. Okay, so yes or no. So this is this nominal variable which will be no which was not there in the earlier case. So here I will show you to you how does it affect. Okay, and here age is continuous. So how these independent variable no can be used for predicting the purchase behavior of the customers in the future. Okay, whether which particular income group will say yes and which will no say no. Okay, and how does it influence. So now I go to the no using the SPSS software. SPSS software is okay. Now customer purchase behavior, I have it here. Okay, you have to numberize it. Okay, you have to numberize all the, if you don't numberize, you cannot calculate, you cannot proceed with the analysis. So here if you see, I have the ID of the customer, age of the customer, gender of the customer, income, browsing time, promo clicked, purchased, whether purchased or not. And this is already which as I have no, done it. I will just delete this. Okay. Okay. Now here, if you see, gender is no, categorized as 1 and 2. And here promo clicked is the output variable. This is the output variable, outcome variable, and dependent variable. Okay, that is 0 means not sorry, it is not a dependent variable. Sorry, it is a independent variable, not promo clicked, and 1 is promo clicked. Okay, and dependent variable is purchased, whether 0 means not purchased and 1 is purchased. Okay, you can have a few more variables from the Likert scale also, and you can include that as a continuous variables, and you can proceed with the analysis. Okay, so when you look into the data view, you will have this no, values. Age is continuous, gender is nominal, income continuous, browsing time continuous, promo clicked in no, category, nominal category, and purchase as the dependent variable, which is the nominal or categorical nature. Okay, so here I'll go to analyze. I've explained to you earlier how to proceed with it. Regression. Okay, go to the binary logistics. Okay, and here I will reset it. Resetment, it will empty the box, all the boxes. And now dependent variable. What is a dependent variable here? It is a purchase variable, whether they have purchased or not. Okay, and I have considered the no age factor, browsing time, and the promo click. Okay, so here promo clicked is a categorical variable. So what you should do is you should go to the categorical option here, which is there here, right side of the box. Okay, and here, see here, it is automatically taken the categorical variable into the box. Okay, if it has not been entered, you have to take carry over here. Okay, then continue here, and then go to options, click the classification plot, horse mode plot, and the CI exponential beta value 95% degrees of freedom. Okay, continue here. Let me check whether I have taken the this one as my independent variable. I have taken the, no, I didn't, age I have taken, sorry. Okay, fine. Customer, okay. So here, click it. Okay, save option. We can save the group membership and the probabilities. Continue. Okay. So you see here that the group predicted group membership is being saved. Okay, I have taken 100 sample here. So we'll go to the output. Okay, output has been generated. Here you can see the output here. Output table. I hope the output table is visible to you. So if you see the output table, you start from here the no, block 1 method, enter here. So here model is no, giving chi-square value and the significance value. Okay, and then next is the okay, model summary, where it gives you the R-square values. Okay, the likelihood is 73.555. One of them, yes. Okay, here R square is 0.457, and here the adjusted R square is 0.618. Okay, so it is better off. Next, if you see the name show test, it is 0.164, which is greater than 0.05. It is also a good showing a good fit. Okay, then next, if you go to the classification table, the classification table shows you the 85% of the accuracy. Okay, so here it's no, out of the 70 100 samples that has been taken, no 53 is being correctly no predicted under the not purchased category, and 32 are being correctly predicted under the purchased category. So only 7 in the not purchased category and 8 in the purchased category are not matching with it. Okay, so this is acceptable, and 85 is a good no fit classification matrix. Okay, so next we show the, okay, we can also go to the ROC. We can check, which is there at the bottom, analyze ROC curve. 1 minute. Analyze ROC curve. Okay, click OK. Okay, so here you have to take the predicted group that you have saved have to be taken as the test variable, and the state variable you have to take the actual purchase category. So as I mentioned to earlier, you have to take the higher level. It is mentioned as 0 and 1, right? Where 0 is not purchased and 1 is purchased. So we take it as here as 1, and with the diagonal, I have clicked here the diagonal reference line and then click OK. So if you see this particular ROC curve confirms that the classification matrix is accurate, and also the area under control. If you see the area under control, okay, area under control is 0.842. 0.842 is the area under control. Okay, so this is well classified. Okay, and your predicted value is away from the diagonal line or the cutoff line. Okay, so this is well classified. Okay, so after this, you confirm that, you go to the coefficient. So if you go to the coefficient, if you go to this coefficient table here, if you see, you have to check with the significance value. So here age significance value is 0.070, which is greater than 0.05. So it does not have much influence on the purchase outcome. Okay, and then income, if you see, it is 0.00, less than 0.05, and browsing time is 0.001. Okay, again there is significance influence. Then promo clicked, okay, it is put here as 1 because the higher value, the positive value is considered here, and promo clicked is yes. Okay, S, that is what it means. So S, when they take it, we will interpret the results in that perspective. Okay, so that is what the promo clicked variable explains. So this is also significance value is less than 0.05. Okay, so apart from the age, others, all the three variables are clearly explaining the influence on the purchase decision, okay, of the individual. So now we look into the exponential beta value for better explanation. So we will leave out age because it is not significant. We will forget this. So income, when you see, the exponential beta value is 1. So there is not much change. There is not much change because the left hand side is 1, and after the decimal it is 000. So there is not much change or equal change, you can say. There is an equal change if this income is being taken care. But there is not much significant increase or decrease increase in the, because it is positive. Since the beta value is positive, so there is not much, it is there, but not much difference. Okay, not much influence. So here, next one, if you see 1.160. So there is a positive relationship between the purchase behavior and the browsing time. So more the time he browses, there is a likeliness to purchase an item. To what extent? If there is a 1 unit change in the time of browsing time, there is a likeliness or for an 16%. Okay, 16% a change in the purchase behavior. Okay, so that is what and positive behavior. S, okay. That is how you interpret this. Next, promo clicked. It is negative here, and if you see the odds ratio, it is very less. Okay, so here there is a decline. You can say that if promo click is not been done, okay, not been done, so that it shows a negative relationship. That is, they will not purchase the product. So that is how you try to explain it. Okay, so I have put that in the word format also. You can check it. Okay, and the same step by step format I have given it to you. Okay, and table one, the data I have carried over here and pasted here. Okay, and you can see the ROC curve here and the coefficient table. Okay, and here there it was mentioned as no, can you remember the ROC curve that was mentioned there? Area under control 84.842. Okay, so here I will write it as 0.842. Okay, so this is the area under control, which is good enough to classify. And these are the things that I have mentioned here. So you can see the explanations that are mentioned. So promo click, when you see for every 1% one increase in the promotional click, there is a decrease in the, to what extent it will decrease? It will decrease to 98%. Okay, lower for those who did not click the promo. So that is the how you have to explain the this one, and this you need not show it. Okay, so from this what is understood is more time when they are spending with the website, it is showing a better result in the purchase behavior. So that is what the exponential variable it shows. First one this, and next is the income. The equal 1 unit increase in the income level, there will be a equivalent increase in the purchase. Okay, so that is one. But here in browsing time, it is 16% more. Okay, so that is how we try to interpret the results. Okay, so this is through the SPSS. So now I will show you through the PSPP software. You can download from the open source. Okay, and let me go with the PSPP. PSPP is a very good source for data analysis. Okay, if you don't have access to the SPSS in your laptop, you can go with the yes. So I hope you can see. Sir, you can see the PSPP software?
Yes, ma'am, I can see it, ma'am.
Yes, sir.
Yes. Yeah. So now here it is empty, right? This particular window is empty. The data Excel sheet, the sheet is empty. So to open you can open with the SAV SPSS file, saved file also, or Excel sheet also. So here go to the open file, go to open, and then go to file and then open. So I have saved the file in my drive. Okay, so I'm going to open it, FTP and logistical regression. So here first I will do with the marketing. I will go ahead. So if you see here, I have 1 minute. Here, let me data file. Asking for, yeah. See here in the bottom, you can see there are options. Okay. So system files, SAV file. Okay. You can open it here. There is no option for Excel. There is an option for SAV. SAV means from the, no, you can, your SPSS package, you can save it, or from Excel Also you can do it. Okay, I'll show you how to do it with the Excel also. So already this is SPSS package is there here. So I have selected the no the data sheet and then open. Okay, so here you can see the data sheet with the variable view. Similar to SPSS, there are data view and variable view. So here the no difference between the SPSS and PSPP is in PSPP there is a limitations of the tools. Okay, if you see the analysis, so these are the only available tools that you can do it in this PSPP. But these are enough for a research work like applying for bivariate, univariate analysis, factor analysis, regression, etc. But for SEM and all, this cannot be used. Okay. So now the variables is there also. You can see the data are there in the data view. Okay. Now similar to this, you can go to analyze. Okay. Go to regression. Okay. There are only two options given here: linear or binary logistics. You can click the binary logistics here, and under the dependent, select the purchase variable here. You know that it is in no yes or no category. Okay, you can check in the variable view whether it is mentioned as nominal or not. Okay, and then you can take age. We can skip the age factor also, as you know that the age does not influence no towards the purchase, right? Because we got the significance value as greater than 0.05. You can skip and also do it. Let us see how the data comes when we skip it. Okay, promotion category here. Okay. So here you don't have you have options where you are just get the option of no the exponential beta value to be 95 percentage. Other options are not there in this PSPP. Okay, then click OK. Then your output will be generated. Okay, so this is the output. Can you see the output? Sir, can you see the output? It is very small. Uh, Let me see whether I can increase the size. I'm not able to increase the size. Sir, can you see it?
Yes, ma'am, it's visible.
Okay, okay. So here also you have the see model summary where the R square values are given. Okay, the chi-square value is not given here. The omni test is not given here. It is straight away starting with the no R square value and log likelihood test value, and some variations will be there. Okay, but not much. Some variations 0.10 or 0.20 like that it will be there, but not much difference. Okay, so when you see here the classification model here, it is showing as the 81 percentage. Okay, so their cutoff may be different in the inbuilt software that they are using it. Okay, it might be in the SPSS, the default cutoff value is 0.5. Okay, so in this, I'm not sure what is the cutoff value here. Okay, so in this also it is given 0.5, but I don't know why there is a difference. But as I mentioned to you, there will be slight variations. Okay. So SPSS is a better no software than the others. That's what we can conclude. So here, no, the prediction table is given, and 81% classification accuracy value is there. And here also, if you see the coefficient, okay, further when you see all are no showing less than 0.05. Here, I didn't take the age factor, age variable I didn't take. Okay, and here it shows that the income is having an exponential beta value of 1, and browsing time beta value is 1.15. So there is a 15 percentage increase in the purchase outcome, and promo click is 2 percentage. Okay, 2 percentage less. That is 98 percentage, 98 percentage less in the because it is negative. You have to talk from the negative side of the outcome variable. Okay, so this is a interpretation for this particular case, right? So this is how you know use it in the PSPP. Okay. So other tests also you can use, as I think sir has explained to you in the previous session. Okay, I will close this PSPP. I will also show you the Jamovi, which is also an open source software. Okay, in that is it is more limited than PSPP. It will give you very limited outcome. Okay, so I will go with the say Jamovi. Okay, it's open source. You can download it and install in your. Okay. So can you see? Can you see the screen? Can you see the screen?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Yes, yes, yeah. So here, if you see, the Jamovi software will give you two windows parallelly. Okay, two windows parallelly. The right side, left side is the data view window. Okay, where you can view your data, and on the right hand side you can as you know go on clicking your analysis. Okay, the output tables will generate in the right side. Okay, so that is what. So but you can also you can drag on the windows like this. Okay, so but if you want to see parallelly, you can do it. You can keep half like this, and you can do it. So now we want to open the data. Okay, you can open the data. Okay, you can export or you can open it. Sorry, not export, sorry. Import, you can open. I want the data from this particular PC. I can browse it here. Okay, so it is showing both Excel and the one. I'll go to the marketing. We will see what difference it no it creates. Okay, so I'll go with the marketing data. So here you can see. I'll try to open the Excel sheet here and try to open. Yes. Can you see? Can you see the data here?
Yes, ma'am.
Yes, you can see the data here, right? Okay. So now go to the regression. So all the variables are here. Okay, all the variables that you are going to consider are here. And go to regression. Go to regression. Then go to the two outcomes binomial. Okay, because see it's written here logistic regression. You have other no partial correlation linear regression. You also have logistic regression. Under the logistic regression, here we have two outcome binomial. So there is another option for no logistic regression. You can use n outcomes multinomial and more than two outcome variables. Okay, so but our limitation here is that we are using only two outcomes. Okay, yes or no, loyal, disloyal, etc. Okay, so now click that. Okay, so this particular window will appear where you have to enter the variable. Okay, and on the right side you see the results being simultaneously being built. Okay, the tables are being already built. So here you can click the income variable. Sorry, you can click the purchase variable, which is the okay here dependent variable, and income continuous variable on the covariates. Browsing time is a continuous variable on the covariates, and you can see here below factors. The factors here we have to take the nominal variables. Okay, categorical variables. So promo clicked is a yes or no category value. Okay, so click here. Okay, you have to click it here. So now we will see. You can see an arrow mark here. Okay, so here if you see it will hide. So when you enter all the variables here, okay, it will give you the output automatically on the right hand side. So it is given you the model fit one. So this is no 0.429, which is greater than 0.05. It is good fit. Okay, and the classification is 77 percentage. Sorry, classification is 85 percentage, and this I'm not sure. Okay, I will let you know what is the deviance. Okay, next when you see the estimates, the estimates and the no, coefficient table, all these independent variables are showing less than 0.001. So it shows that it is less than 0.05. Okay, generally when you know go for the analysis, you can take 1%, 5%, or 10%. To that, three different no, level of significance you can conclude your significance level, probability level. Okay, so here you can say all are no, less than 0.05 or 1%. Also, it is significant. When you take income, it does not give the this one. What is that? Exponential probability value. It just gives the estimates. Okay, so when estimates is given, you can see the probability is no income level. It is 0.000 something. When you click this, it has not been happening. Okay, so when income and is shown like this, it is shows at 0.00 4 zeros and then 9. Okay, point 4 zeros and then 9. So it is 0.0009. So very meager change in the income dependent level due to income level. Okay. Then browsing time. Okay, browsing time is 0.140, and promo click this 3.716. Okay, so it is shown as 1 to 0. So it shows that it's a negative relationship. Okay, so you have to talk about that. It will the the percentage of no people who don't purchase because of not clicking. Okay, so that is what is being explained here. Okay, so this is very simple on the Jamovi platform. You can use for your MBA level analysis. You can do this analysis. Okay, but for PhD and all, you have to go for more better explanation, like what was explained in the SPSS. Okay, so this is the you can I think there is also a you can click it here if you want need the other no, below you have. Okay, Niagara square value, if you have, you click it, you will get it here. Okay, overall model test also you can click it, so you're getting it. Okay, you're getting it here, chi-square value that was mentioned there. But here they may use a different chi-square model. So model coefficient is already being given. Prediction you can see in Jamoi. Cutoff is no 0.5 here. Classification table if you want, accuracy if you want, ROC curve if you want, AUC. Okay, you can click it here. Okay, if you click it, everything will be displayed below it. See if you see here. So this is classification table. It is showing that. Okay, 85 correctly been done for the 0 category, and 1 it is 75. Overall, it did not give accuracy. Okay, accuracy is here as 0.81. Okay, and the specificity and sensitivity will explain the ROC curve. Okay, so and AUC area under control is 0.895. So which is away from the diagonal line, which is a good predictor, right? So this is how you can use your Jamovi also. So Jamovi is also a good source, because I didn't check this all. So I am giving you the option here. You can also save the predicted value. Okay, predicted value. So I hope the predicted value will be saved here, and you can go to the predicted value and check whether it is being saved or not. So here, if you go to data, predicted value is saved, right? Okay. So here in ROC, automatically it will take the predicted value. Automatically it will take. But in SPSS, I showed you that we have to enter that in the dialog box, and then it will no should give you the ROC. But here in Jamovi, it is better. No, here is this. So all the SPSS outputs are being no shown here. The accuracy, specificity, sensitivity, and area under control, the classification table, and the model fit tables, or coefficient tables. Okay, all these are given here. So I hope this also will give you a good piece of insight into the Jamovi, right? Anybody is using Jamovi? Anybody has used Jamovi? So I have finished my no case user, and two different cases I have analyzed, right? I will close all my ones, okay, and go to the main screen, okay. Any doubt you can ask me. I will stop sharing, sir. Any
Yes,
doubt
ma'am,
you
you
can
can
ask
stop
me.
sharing, ma'am.
Yeah, I can stop sharing it. Yes, student, friends, if you have any doubt, you can ask me, or you can also give a mail to me if you have any queries to be made. You can do it. So I will give you my mail ID in the chat box. You can. I'll give you my chat. Okay. You can note down. I hope I didn't take in a very faster manner, or I didn't bore you, right? One of them can give your feedback. One of them can give a feedback.
Ma'am,
What
there is
does
a
one
question.
unit time, income mean? Okay, so suppose say income is mentioned in thousands, right? So if 1,000, 1 unit means 1,000. 1 unit time means, suppose it is in minutes. Suppose it is in minutes, 1 minute. If 1 minute increase, okay. I hope Srinivasan sir, you have got the clarification.
In addition
Yes,
to this,
thank
shall I add, ma'am,
thank you
one
so
more
much.
thing?
Thank you so much. Okay,
So about the software package usage, Jamovi and all, you can refer Murugan's.
hello, sir.
For Jamovi software, you can refer Murugan's YouTube channel. He has been conducted two workshop how to use Jamovi. So you can have that videos also. Anybody is
Sir, I didn't get
particular
you.
in using Jamovi? Any? Participants?
Sir, it is not audible, sir. Shall I speak, sir?
Yes, ma'am. Yes, ma'am. Please,
Okay,
ma'am.
okay, sir's network is poor, so sir, your network is low, sir. Okay, thank you, participants, and you kindly fill up the feedback form and support us in the next 2 days, which will be interesting. Our tomorrow session is the machine learning. Okay, how to get the data from the website, and how to predict the data through machine learning on Python. Simple Python will be used. And the last day with all case use analysis with the help of the machine learning. Okay, sir from the industry expert will come and give his talk. Okay. So I thank my management to give us this opportunity by giving this opportunity to organize this FTP program, and the participants I thank, and my faculty members and the faculty coordinators for making today's session a fruitful one. Thank you one and all.
Thank you, ma'am. Thank you, participants.
Okay, sir.
We will meet
you, ma'am.
tomorrow session.
Thank you,
Thank
ma'am.
you. Thank you.
Thank you, ma'am. Thank you all.
Yeah, yes, sir.
Thank you,
Thank
ma'am.
you.
Thank you.
Yeah.
Ma'am, shall I?
Yeah, close it, sir. Close it.